various thermodynamic processes. Let's begin our journey. Let's start with thermal equilibrium. Imagine you have two bodies, body A at 100 degrees Celsius and body B at 20 degrees Celsius. When these two bodies come in contact, heat flows from the hotter body A to the colder body B. This heat transfer continues until both bodies reach the same temperature. When there is no net heat exchange between the bodies, we say they are in thermal equilibrium. In our example, both bodies will eventually reach 60 degrees Celsius. Remember this Namaste students. Welcome to MAGPIEHUB. Today we are going to study one of the most important chapters for NEET and JEE, thermodynamics. This chapter carries high weightage in both exams. So pay close attention. We will cover thermal equilibrium, zeroth law, first law, second law, and various thermodynamic processes. Let's begin our journey. Let's start with thermal equilibrium. Imagine you have two bodies, body A at 100 degrees Celsius and body B at 20 degrees Celsius. When these two bodies come in contact, heat flows from the hotter body A to the colder body B. This heat transfer continues until both bodies reach the same temperature. When there is no net heat exchange between the bodies, we say they are in thermal equilibrium. In our example, both bodies will eventually reach 60 degrees Celsius. Remember this concept, it forms the foundation of thermodynamics. Now let's understand the zeroth law of thermodynamics. Consider three bodies A, B, and C. If body A is in thermal equilibrium with body B, meaning they have the same temperature, and body B is in thermal equilibrium with body C, then according to the zeroth law, body A must also be in thermal equilibrium with body C. This law might seem obvious, but it is extremely important because it forms the basis of temperature measurement. When you use a thermometer, you are actually applying this law. What exactly is temperature? Temperature is a measure of the average kinetic energy of molecules in a substance. Higher temperature means molecules are moving faster. We have three main temperature scales: Celsius, Kelvin, and Fahrenheit. In Celsius, water freezes at 0 degrees and boils at 100 degrees. In Kelvin, the same values are 273 K and 373 K. Remember the conversion formula. Kelvin equals Celsius plus 273.15. For NEET and JEE, Kelvin scale is most commonly used in numerical problems. Now let's understand three crucial quantities: heat, work, and internal energy. Heat, denoted by Q, is energy transferred due to temperature difference. It flows from hot body to cold body. Work, denoted by W, is energy transferred through mechanical action, like pushing a piston. The formula for work is W equals integral of P dV. Internal energy, denoted by U, is the total energy of all molecules in a system. For ideal gas, it equals F by 2 times nRT, where F is degrees of freedom. Very important, remember the sign convention. Q positive means heat absorbed. Q negative means heat released. W positive means work done by the system. W negative means work done on the system. The first law of thermodynamics is essentially the law of conservation of energy. It states that energy can neither be created nor destroyed, only converted from one form to another. Mathematically, delta U equals Q minus W. This means the change in internal energy of a system equals heat supplied to the system minus work done by the system. This is the most important formula in thermodynamics. Every numerical problem uses this equation. When heat is added to a system, it either increases internal energy or does work, or both. Let's study isothermal process. Iso means same. Thermal means temperature. So isothermal process occurs at constant temperature. For this process, delta U equals 0 because internal energy depends only on temperature for ideal gas. Since delta U is 0, from first law, Q equals W, all heat absorbed is converted to work. The work done is given by W equals nRT ln V2 by V1. On PV diagram, Isothermal process is represented by a rectangular hyperbola because PV equals nRT is constant. For isothermal process to occur, the system must be in good thermal contact with surroundings and the process must be very slow. Now let's understand adiabatic process. In adiabatic process, no heat is exchanged with surroundings, Q equals 0. This happens when the system is perfectly insulated or the process is very fast since Q is 0. From first law, delta U equals negative W. If work is done by the system, internal energy decreases and temperature falls. The relation PV to the power gamma equals constant holds for adiabatic process, where gamma is the ratio of specific heats. Important point. On PV diagram, adiabatic curve is steeper than isothermal curve. This is a common question in NEET. For monoatomic gas, gamma is 5/3. And for diatomic gas, gamma is 7/5. The second law of thermodynamics has two equivalent statements. Kelvin-Planck statement says, it is impossible to construct a heat engine that converts all heat into work. Some heat must always be rejected to a cold reservoir. Clausius statement says, heat cannot spontaneously flow from a colder body to a hotter body without external work. Both statements are equivalent and tell us about the direction of natural processes. The efficiency of a heat engine is given by ether equals 1 minus T2 by T1, where T1 is source temperature and T2 is sink temperature. This is Carnot efficiency, the maximum possible efficiency for any heat engine operating between two temperatures. Finally, let's understand reversible and irreversible processes. A reversible process is one that can be reversed completely, leaving no change in system or surroundings. It is quasi-static, infinitely slow, and the system remains in equilibrium throughout. Examples include isothermal and adiabatic expansions done very slowly. Irreversible processes cannot be reversed. They occur at finite rate and involve dissipation of energy. Examples include heat conduction, free expansion, and processes involving friction. Important. For reversible process, change in entropy of universe is 0. For irreversible process, entropy of universe always increases. This is another way of stating second law. Now some crucial exam tips for NEET and JEE. Tip 1. Always remember sign convention. Q positive means heat in. W positive means work by system. Tip 2. For ideal gas, internal energy depends only on temperature. Tip 3. Adiabatic curve is steeper than isothermal on PV diagram. This is frequently asked. Tip 4. Work done equals area under PV curve. Tip 5. Carnot efficiency depends only on temperatures. Tip 6. In cyclic process, delta U is 0, so Q equals W. Tip 7. In free expansion, W, Q, and delta U are all 0 for ideal gas. Master these points and you will ace thermodynamics questions. Thank you so much for watching this complete lecture on thermodynamics. I hope this video helped you understand all the important concepts clearly. If you found this helpful, please like this video and subscribe to MAGPIEHUB for more NEET solutions and JEE preparation content. Hit the bell icon to get notified whenever we upload new videos. Keep studying, keep practicing, and success will be yours. All the best for your exams. Jai Hind.